In this lesson, we're going to look at writing and graphing linear inequalities. So how do I graph linear inequalities? Our first step in graphing linear inequalities is going to be to solve for y. So let's go ahead and look at the inequality down here, and let's solve for y. So we want to get y all by itself. Let's minus a 2x minus a 2x. Negative 3y is less than 12 minus 2x. Alright, so now that negative 3 is multiplying, so we're going to divide by a negative 3. And again, remember, when you divide by a negative, you need to flip a sign. Alright, so y is, I'm going to flip my sign, and then I'll have negative 4, and then plus 2 all over 3x. Alright, so now I've solved for y. Alright, our second step in graphing linear inequalities is now let's graph this inequality. So I'm going to start by going to our negative 4, and then I'm going to go up 2 over 3. I'm going to do that a couple of times, up 2 over 3. So our third step is we need to determine if it's a solid or a dashed line. Let's talk about the difference in the lines. You will use a solid line when you see an equal sign, when you see a greater than or equal sign, or you have a less than or equal sign. You will see a dashed line when you have a greater than or when you have a less than. So because we have this inequality sign here, y is greater than negative 4 plus 2/3 x, we are going to graph this using a dashed line. Because what that means is that it is going to be anything that is greater than negative 4 plus 2/3 x. It's not going to be equal to. So anything on the line is not going to be a solution. So let's take a look at our fourth step, which is to shade. Now, if you solve for y, then you could determine with the direction the inequality sign is facing, if it's going to be shaded up or shaded down, above the line or below the line. Because I have y is greater than, what I'm going to do is I'm going to then shade above it. So shading above the line is when you have greater than or equal to. Shading below is when you'll see less than or equal to. So because this is y is greater than, I'm going to shade everything that's going to be now above that line. And this is how you would graph this inequality. All right, so let's do some more examples. Remember, step number 1 is to solve for y. Well, in this number 1, it's already been solved for y. So let's go to step number 2. Step number 2 is to graph the inequality. So let's start. I have a y-intercept of negative 2, and I have a slope of 1, so it's going to be up 1 over 1, up 1 over 1. Our third step is to determine whether it's going to be a solid line or a dashed line. Because this is greater than, I'm going to then have a dashed line. The fourth step then is to determine if you're going to shade up or shade down. Because I have y is greater than, I'm going to shade this one going up. So anything that you would find in anywhere in that shaded area, those coordinates are going to be solutions to this inequality. Now, because it's greater than and it's not greater than or equal to, anything on that dotted line is not going to be a solution. Now, sometimes it's confusing for us to know which way is the shaded up or the shaded down. So a lot of times what we'll do is, and we'll pick this point 0, 0. We're picking that point because it's an easy one to plug in for the inequality. So what I would do is I'd come back up to my original equation or my inequality, and I'd plug in 0 for y is greater than x is 0 minus 2. Then you ask yourself, is 0 greater than negative 2? And it is greater than negative 2. So you know that you're going to be including 0, 0 is one of the solutions of this linear inequality, so therefore you would be shading in that direction. If it didn't include that, you would shade in the opposite direction. All right, so let's take a look at this next example. We're going to take negative 6x minus 2y is greater than or equal to 4. All right, so remember the first step is to solve for y. So let's take, I'm going to rewrite my problem right here. All right, so let's solve for y. We're going to plus the 6x negative 2y is greater than or equal to 4 plus 6x. Let's divide by the negative. Now remember, we're dividing by the negative, so we have to remember to flip our sign. Y is then going to be less than or equal to negative 2 minus 3x. All right, so that's step number 1. Step number 2 is let's graph it. I have a y-intercept of negative 2, so I'm starting at the negative 2. And I have a slope of negative 3. So I'm going to be going down 3 over 1. Step number 3, determine whether it's a solid or a dashed line. I'm going to go back 1, 2 this way. Okay, so because this is less than or equal to, because you have that equal to in there, it's going to be a solid line. It's like your solid dot when you graph the other inequalities with one variable. So we're going to then have a solid line. And so anything that's on that line is going to be a solution, and it says less than or equal to. So anything underneath the line is going to then also be, so you're going down. Sometimes it's confusing to know if you, which way is down and which way is up on the graph. One way to determine is to pick a point. I always pick the point 0, 0, just because it's easy to place in there. And I'm going to plug it into my equation. So if I have negative 6 times 0 minus 2 times 0, is that greater than or equal to 4? So this is going to be 0 is greater than or equal to 4. Now, is 0 greater than or equal to 4? No. So we know that that point 0, 0 is not going to be a solution to that inequality. So therefore, I know that I have to shade in the opposite direction. All right, so let's take a look at the y is greater than or equal to negative 3. Remember, in equations or inequalities like this, in every case, y is going to be 3. You can make that little xy table and just say negative 3, negative 3, negative 3, and then pick some points, 0, 1, 2. So I'm going to have negative 3, or 0, negative 3, 1, negative 3, 2, negative 3. So if you're questioning, just make that little xy table that way. So now the next step then is to determine solid or dashed. Well, because this is greater than or equal to, I'm going to then have the solid line, and then I'm going to shade up. It's going to be above the line here. And again, you can plug in the point if you'd want to. I can plug in, let's just pick that 0, 0 and see if is 0, 0 a solution to this inequality. Is 0 greater than or equal to negative 3? Because 0 is greater than or equal to negative 3, I know that I've shaded in the right direction. So in our next example, we have the x is less than 1. So in every case, remember, x is 1. All right, 1, 0, 1, 1, and 1, 2. There we go. Now, you need to determine, is it going to be solid or dashed? And because it's just less than, you're going to then do the dashed line. And now is it to the left or to the right? Well, less than is always to the left. Greater than is always to the right. And again, test a point. And if it works, you know you're shading in that direction. If it doesn't, then you know to shade in the other direction. So is 0 less than 1? Yeah, 0 is less than 1. And notice 0, 0 is one of the solutions to that inequality. So in our third example, we're going to be writing linear inequalities. Just like writing linear equations, you need to have the two things. You need the slope and you need the y-intercept. So let's start by determining the slope, and let's find the y-intercept. So our slope and our b, the y-intercept. So our y-intercept is right here, which is at 2. And our slope, let's pick 2 points. And pick that point and that one point, make it easy. And I'm going down to -2 and over 3, giving me a slope of -2/3. So now let's write it, the linear inequality. I have y is, now, because it's being shaded down, it's going to be a less than. And we also know it's going to be a less than because you have the dashed line. If it had a solid line, it would be less than or equal to. And now let's just put our slope and our y-intercept in. -2 all over 3x plus 2. All right, let's take a look at the next one. Again, I need two things. I'm going to need my slope. I'm going to need my y-intercept. Let's start with our y-intercept. Our y-intercept is at -1, 2, 3, 4, 5, 6, 7. So -7. And then I'm just going to pick the next point. I'm going up 1 over 1. So my slope is +1. So I have y is, now we have to determine what our inequality sign is. Now, because it's below the line, it's going to be y is less than, and then it's a solid line, so it's less than or equal to. And now I can just put in my slope and my y-intercept, 1x minus 7. And for our last one here, I need two things, the slope, the y-intercept. This one's a little bit more difficult to do that way. This is one of those special equations or inequalities. Let's just go ahead, let's kind of look at where our points are. I've got all these points along this line right here. And those are going through my x, it's going through my x-axis. And I could, if I wanted to, I could do this xy. And I could say I have -1, 0, I have -1, 1, -1, -2, and so forth. So those are some of the points along that line. And in every case, notice x is equal to -1. So this is at x is equal to, or x is, now it's going to the right. So it's going to be greater than, and then since I have a solid line, or equal to then -1. So in this lesson, we took a look at how to write and to graph linear inequalities.